Okay, let's talk about inserting geometric means between two numbers. Okay, just now we have learned about basically geometric means. Okay, we have learned previously about the geometric mean, which is nothing but we can say that between two numbers geometric mean if a and b are there, and if g is a geometric mean, so z is nothing but under root of ab. But instead of that, if I have n number of terms, or if I want to insert some 5, 3, 4, any number of terms inside the geometric series, or inside the first and the last term, or whole series I want to insert inside first and like between two numbers. So what will happen? What are the changes will be there, and how to find the terms? Okay, so what will happen here is, if I have a number a as a first number and b as a last number, and inside we have the term which is nothing but ar square ar to the power n minus 1, and so on up to, okay, they are ar cube, and here I can add ar to the power n minus 1. Okay, so basically n number of term I'm inserting in between them. So definitely, as you know, these are n number of terms. Okay, we can say that n number, and a and b are two extra terms. So totally how many terms we have? N plus 2 terms. Okay, so we have number of terms n plus 2 is equal to total terms. Okay, now since we have total number of terms n plus 2, what will be the nth term? So we know that a is my first term, b is my last term, and a is my first term. Okay, and total number of terms are, we have n plus 2. So according to the Tn formula, means general formula, or the nth term formula, we can say that Tn is equal to a into r to the power n minus 1. Okay, so common ratios are, so we have to find the common ratio only. So Tn is, if we are talking about finite series where we know the last term, so we can write as this L is equal to a is my first term, r, and total number of terms are n plus 2 minus 1. So with what we got as L, what is L here? B, the last term, so a r to the power n plus 1. So r is nothing but b by a whole to the power 1 by n plus 1. So this is my common ratio, which I have already written there. This is my common ratio. So as we know, my z, this is my first term, so this will be my second term. Okay, so see, don't get confused with this. I have written this to make you understand. So I should write this as g1, g2, g3, and up to zn. So for that, if my series, I write this series as back also. If my series is a, g1, g2, z3 up to gn and b, so for that series my ratio, our common ratio is this I've given, and so my a is the first term, and what will be z1, which is nothing but ar. Okay, so ar is nothing but b by a to the power n plus 1 by n plus 1. So this is my g1. Similarly, g2 will be ar square, so I'll substitute the r value there and I'll get the answer. So this is what we have from the GP. We can insert by this using using this formula. We can insert n number of terms in between the two numbers. We can say that the n geometric means. Okay, and if I'll talk just about two numbers again, so if I'm talking about two numbers a and b, so in that case my product of n gm inserted between a and b is equal to nth power of the single gm a and a between a b a between a and b, and we can say that this is the my rule, where g is nothing but under root of a. So what I said, product of n gm means if I have g1, g2, g3, g3 up to gn. So if I'm multiplying g1, g2, g3 and up to gn, if I'm multiplying all these things, so what will happen by multiplication? So the answer, final result will be there, which is nothing but the g whole to the power n. Means if we have a n number of terms and 10 terms, means g will come as 10. The nth power of the single gm. So single gm means if I'll find a single g, this is my single g. So if I'll keep this value here, so answer will be g to the power n. Okay, hope this thing is clear to you.